Importing libraries. In Dart, we can import libraries to use the functions, classes, and other resources they provide. This is done with the import statement, followed by the path to the library. You can import both system libraries and third-party libraries added via the Pub Package Manager. The provided code imports the material library from the Flutter framework, giving access to a wealth of UI components and utilities for building a Flutter app. To use the material components, one must precede this statement at the beginning of the Dart file. Using libraries. In Dart, you can use core libraries which come bundled with the language to provide functionality like math operations or input-output features. This code imports the core library Dart Math, which brings in math-related functions and constants, such as pi. Then it uses pi to calculate the area of a circle with a specified radius. Lazy loading with deferred loading. In Dart, lazy loading, also known as deferred loading, allows an application to load a library on demand. This can reduce the initial load time of an application by splitting the application into several smaller chunks and loading them only when they are needed. The code demonstrates how to import a library deferred using the deferred as keywords, followed by a custom prefix, myFeature in this case. To load the library, call load library on the prefix, which returns a future. Once the future completes, you can use the library's functions or classes as you normally would. Here, doSomething is a placeholder for a function within the mylib's myFeature.dart library that you want to use after the library has been loaded. This approach can significantly improve the performance of an application, especially if it has a large amount of code that is not always necessary during the initial startup. Visibility, public and private. In Dart, visibility is controlled by the naming convention of the identifiers. Identifiers that start with an underscore core are private to the library in which they are declared. Those without an underscore are public and can be accessed from other libraries. In the provided code, private greeting and generate private greeting are private to the greeter library, indicated by the leading underscore. They can only be accessed within the same library file. Contrastingly, public greeting and generate public greeting are public and thus can be accessed from outside the greeter library. The private members are hidden from other libraries, providing encapsulation and the ability to change the internal implementation without affecting other parts of the program. Exporting features. In Dart, libraries can export part of their functionality to other parts of an application, allowing you to organize and share code. When you use the export directive, you make the specified library's public API available to other libraries that import your library. In the given code, we have a library named exporter. It uses the export directive to export the contents of some private library.dart, which is located inside the src folder. By doing so, any other library that imports exporter will also have access to the classes, functions, and variables defined within some private library.dart as long as they are public, not prefixed with an underscore. Pub tool. The Pub tool is Dart's package manager, used for managing Dart packages. It helps with package discovery, installation, and version management. Pub is included with the Dart SDK, and it offers a set of commands, such as pub-get for retrieving package dependencies, pub-upgrade for updating packages, and pub-publish for publishing packages to the Dart package repository, pub.dev. It uses a pubspec.yaml file to manage package configurations. Creating a package. In Dart, a package is a structured collection of files that include Dart code, resources, and a pubspec.yaml file, which defines the package. To create a package, follow these steps. The code block is a simplified version of what might be found in a pubspec.yaml file used for Dart package management. The name key specifies the package's name, version sets a starting version number, and description gives a brief summary of the package. Under dependencies, you list other packages your package relies on. In this case, Flutter is a dependency. For packages needed only during development, like for testing, use dev dependencies. The remainder of the pubspec can include additional settings, such as Flutter-specific configurations. Publishing a package. To publish a package to the Dart package repository pub.dev, you must prepare your package correctly, verify its dependencies, include a proper pubspec.yaml file, and follow the guidelines for package publishing. Here, you'll see how to use the pub command line tool to publish your package. The pub publish command is used to publish your Dart package to pub.dev. Before running this command, ensure you have a pubspec.yaml file in the root of your package directory with the necessary information as described in the Dart package layout conventions. The pub tool will perform several checks before uploading your package, such as formatting, analyzing for errors, and checking for any potential privacy leaks in the file system. If everything passes, you'll be prompted to confirm the upload, and once confirmed, your package will be published on the pub.dev repository. Dependencies Management. In Dart, dependencies are managed in a pubspec.yaml file, which is located at the root of your project. This file specifies the packages your project depends on, along with their versions. To add a dependency, you need to add it to the Dependencies section of your pubspec.yaml file. After adding or updating dependencies, you run the pubget or pubupgrade command to fetch the packages from the Dart package repository. In the given code snippet, you can see a segment of a pubspec.yaml file where the HTTP package is added as a dependency with a specified version, 0.133. The caret before the version number means that this project can work with any version of HT that is compatible with 0.133, allowing for flexible version solving. Additionally, it notices how the Flutter dependency is associated with the Flutter SDK, indicating that this package is for a Flutter project. Using version constraints ensures that your project does not break when new versions of dependencies are released. Writing unit tests. Unit testing involves testing individual units or components of a program to validate that each segment of the code performs as expected. In Dart, this is typically done using the test package, which provides a framework for writing and running tests. A basic unit test checks a single function, method, or class. The provided code block imports the test package. Inside the main function, a test case is defined using the test function, which takes a description and a callback. Inside the callback, a variable answer is assigned the value 42. The expect function is then called to check if answer equals 42. This will pass since the values match. The expect function is the primary assertion mechanism in Dart's unit testing. Using the Dart test package. The Dart test package is a powerful set of tools that allows developers to write and run tests for their Dart code. It supports unit tests, which test individual parts of the code, and more complex integration and end-to-end tests. This example shows how to set up and write a simple unit test. In the code above, we import the Dart test package. In the main function, we define a test called myUnitTest using the test function. Within it, we declare a variable number with a value of 42. We then use the expect function to assert that the value of number is indeed 42. The test will pass if the assertion is true, and fail if it is not. Debugging techniques. Leveraging print statements is a simple yet effective way to debug Dart applications. By printing variable values and program states to the console, developers can trace the execution and identify where things may be going awry. The code demonstrates a basic function, addNumbers, that incorrectly calculates the sum of two integers due to a deliberate bug. An extra one is added. Print statements within main and addNumbers show values of sum and result, aiding in identifying that addNumbers is not functioning as expected. Asserts in production code. In Dart, the assert statement is used during development to disrupt normal execution if a Boolean condition is false, helping programmers find mistakes in the code during the development phase. However, by default, assert statements are ignored in production code, meaning they will not execute and therefore do not impact performance in a production environment. In the provided code snippet, the assert statement checks if the given value parameter is less than 100. The second argument to assert, which is a string, provides a message describing the assertion failure. If this assertion fails during development, for example, if value is 100 or more, it will raise an assertion error and print the message, helping the developer to notice and correct the mistake. However, in production, the assertion will not execute, and thus the overhead is non-existent. Compression tools might remove these asserts altogether during the production build process, as they only serve a purpose during development and testing. Using observatories. The observatory is a tool for profiling, examining, and debugging Dart applications. It provides insights into the behavior of a Dart program, allowing developers to analyze and optimize their code. Here's how you can use it. This simple code snippet prints a string to the console. To use the observatory, run your Dart application with the observe flag. For example, use Dart observe program.dart in the command line. The observatory provides a web interface that you can open in your browser at http://7.sto.1a1a1/. From there, you can access various tools for debugging and profiling your application, such as viewing active objects, breakpoints, and call stacks, and monitoring the garbage collector. Isolates. In Dart, all code runs in an isolate, and each isolate has its own memory heap, ensuring that no isolate state can be accessed by any other isolate. Isolates are perfect for doing work in a separate thread, thus achieving concurrency. They communicate by sending messages through ports, send port, receive port. The code above demonstrates the use of isolates for concurrency in Dart. A main isolate creates a receive port to listen for messages. It then spawns a new isolate with isolate.spawn and passes the send port of the receive port to it. Afterward, the main isolate sends a message to the new isolate, which sets up its own receive port. Upon receiving a message, the new isolate replies back by sending a message through its send port. The main isolate receives the echoed message and prints it. This is an example of how isolates can communicate asynchronously and run code in parallel without sharing memory. Concurrency primitives, futures and streams. Futures in Dart are a core part of the language's concurrency model. A future represents a potential value or error that will be available at some time in the future. They are used for potentially time-consuming computations, such as I/O-bound work, that shouldn't block the main thread. In this code snippet, fetch user data is a function that simulates fetching user data with a delay of 2 seconds. The future.delayed constructor is used to create a future that completes after a specified duration. The main thread can continue executing other tasks while waiting for the future to complete. Calling JavaScript from Dart. Interoperability in Dart refers to the ability to interact with JavaScript (JS) code. This is essential in scenarios where you might be working with browser-based or Node.js environments alongside Dart. To interface with JavaScript, Dart uses the JS package, which provides facilities to interop with JS code seamlessly. In the code, we first import the JS package, which enables JavaScript interop. We then use the @JS or annotation from the package, denoting that the declared members are to be looked up in the global JavaScript context. The external keyword is used to define an abstract method that is implemented in JavaScript. Finally, in the main function, we call the getJSAstring method as if it were implemented in Dart, when in fact it refers to a JavaScript function with the same name. Calling Dart from JavaScript. In web development with Dart, there are scenarios where you may want to call Dart functions from JavaScript. To achieve this, Dart provides the Dart.js and Dart.js util libraries, which enable interoperability between Dart and JavaScript in web apps. The process involves exposing Dart functions to the JavaScript context so they can be invoked from JavaScript code. The code sample illustrates how you can expose a Dart function to be callable from JavaScript within a web application. Using the Dart.js library, we register the greet-from-Dart Dart function in the global JavaScript context, effectively making it accessible to JavaScript code. Afterwards, within the JavaScript code, the call Dart function JavaScript function invokes greet-from-Dart as if it was a regular JavaScript function, passing in an argument, and logs the result. This showcases basic interoperability, where Dart functions can be treated like JavaScript functions in the browser environment.